Now that we got a good understanding of what VLANs are and we've configured it on the switch, now we can get more in depth into what VLANs are. So in this video, we're going to get more in depth into VLANs and talk about some of the details of VLANs. So in this video, we're going to start out by talking about interface types. What's an access port? What's a trunk port? What's a SVI? And then we're going to get into types of VLANs. What are the different types of VLANs that you would assign on your network, and what does that look like? Then we're going to get into the VLAN.dat and just briefly talk about the VLAN.dat file. We'll get into a VLAN Trunk Protocol, or VTP, and talk about what VTP is. And then we'll finish it off by talking about VLAN IDs and some of the ranges in VLAN IDs that you can assign to your different VLANs. We're going to talk about 3 different types of interfaces when it comes to VLANs. A access port or access interface, a trunk port or trunk interface, and a switch virtual interface, or SVI. So let's talk about those 3 different types. I'm going to use this network diagram as an example throughout this video. And so what I have here is I've got some laptops, I got some phones, I've got some switches that are connected, and we have different VLANs set up, or they're the same VLANs. We got multiple VLANs set up on these different switches right here. Now, the first type of port there is, or the first type of interface, is an access port. An access port is one that's assigned to a single VLAN. So for instance, our laptops are connected into this device right here, and they have a single VLAN that's assigned to them, and that is what's programmed on that switch. So then they're just talking on that one network. The second type of interface is a trunk port. And so a trunk port is those that are communicating from device to device that may have multiple VLANs that are crossing across that path. And so as an example of this is these interfaces that are between these devices, switch to switch, switch to router, are probably have multiple VLANs that are communicated across those interfaces. Otherwise, what you would have to do is you'd have to have as many VLANs as you have, you'd have to have multiple lines of traffic that are communicating for each one of those VLANs. So instead, we can actually just go across one line and be able to tag that traffic. And we'll talk much more in depth about trunking in a later video. And then the final one is a switch virtual interface. And a switch virtual interface is a virtual interface. So it's not a physical interface that shows up on these switches, but it is a virtual interface. And that virtual interface could be serve many different purposes, but for one of the purposes is maybe it's for management of that switch. And so you would assign an IP address on that interface, and then you'd be able to communicate to that device through that switch virtual interface. And there's other things that we can do. We can actually do some routing with it, and there's other things we can do as well. But for the purpose of this is just realize it's a virtual interface. We can assign IP addresses to it. It still belongs to a single VLAN, and so that is something that we'll definitely be using on our devices. In fact, since we have a management interfaces on our devices already set up, in fact, we actually have this already. We've created switched virtual interfaces already. Okay, now let's talk about different types of VLANs. And the first VLAN that we're going to talk about is our default VLAN. The default VLAN is the VLAN that's set up on our devices, so that way as soon as you take it out of the box and plug it in, it starts to work. There's just one default VLAN, and that is VLAN 1. So the default VLAN on Cisco switches is VLAN 1. All of these ports, all 50 of these ports, there's 48 fast Ethernet ports, and then there's some Giga Ethernet ports here on the end. All 50 of these ports are assigned to VLAN 1 by default. That way I can plug in this device, get it started up, plug in my equipment to it, and it starts working before I even do any type of configuration. So that's the default VLAN. Another type of VLAN is our data VLAN. These are the VLANs, and I say plural, VLANs plural, because you can have lots of different, and you probably will have lots of different VLANs. And so you have data VLANs is what your devices that are actually communicating across this network. And it's for the end devices. Essentially, a lot of this is the access ports that you have on your device are going to be set up as the data VLANs on your port. We could have a data VLAN for our execs. We could have our data VLAN for our, let's say we're at a school. It could be staff member, administration, students. We'd have VLAN set up for that to break that apart. Maybe we have set up for wireless as well, or one of the colleges that I worked at, one of the universities I worked at, we would break it apart in, well, we would have a student, we'd have a employee network, and then also we duplicate that. We'd have it for the physical when they connected into their devices, but then also wireless if they connected into wireless. So you can break it apart in many different ways, but essentially these are all the end devices are connected to your data VLANs. Then we have the management VLAN, and the management VLAN is designed to connect devices that you need to manage, that you don't want to give your general users access to. So an example of this is, let's say we want to manage all of these switches right here, and we need to set them up so that way we can remote into each one of these switches. But if I were sitting on just a regular device, I wouldn't be able to get into that management VLAN. So we block the traffic from anything except for machines that we'll actually be accessing these devices from. So that's the management VLAN, and the design is to keep your network secure and make sure that people don't have access to the core of your network. Then there is a voice VLAN. The voice VLAN, the key feature to this is it has some sort of quality of service. And so we will plug in our VoIP phones into this, the voice over IP phones into our network, and they will join a specific voice VLAN. And that voice VLAN gets tagged as anything that comes in on that voice VLAN, we want to prioritize that traffic, and that traffic gets handled first. And the reason for that is a lot of your other traffic that comes from your machines is not really time sensitive. But the voice and the conferencing VoIP traffic that goes across your network is time sensitive. To have quality conversations, quality voice conversations, you need to prioritize those packets and make sure they get through before the rest of your devices. So that's your voice VLAN. Typically, you could have multiple voice VLANs, but it just depends on kind of your setup. A lot of times, a lot of businesses will just have one voice VLAN that will prioritize that voice traffic. Then you have native VLANs. The native VLAN is a per trunk VLAN. Okay, what do I mean by that? Is you will assign native VLANs on the trunk ports that you have. And the idea behind this is any of the VLANs that get passed back and forth between two different devices, we have to tag that traffic. We have to identify what VLAN is that traffic a part of. So that way when this switch gets something on VLAN 10, let's say, and passes it on to this switch, then this switch knows that that traffic is coming across for VLAN 10. All right, but native VLAN is the one traffic that goes across that link that is not tagged. And the reason why you have to have that is that there is some protocols, layer 2 protocols that are going across between these two devices that don't have tagged traffic. And so the solution for that is you have this native VLAN for this interface that these two devices then can pass that information back and forth without tagging that traffic. And then they can speak that layer 2 language back and forth, that layer 2 protocol back and forth. So that's the native VLAN. You find it on trunk lines, and it's a per trunk line, and it's the untagged traffic. And we'll talk much more about VLANs and trunking and how we can tag that traffic within a trunk line. So I've already mentioned in prior videos this VLAN.dat. It's a file that stores the VLAN information. And we'll see a scenario here in a couple minutes in this video where there's some information doesn't actually get onto the VLAN.dat, but that's for certain higher extended VLANs that we have. But for most of your VLANs that you would be setting up on these devices, that information goes into the VLAN.dat file. And so it's a separate file. So if you are wiping a switch, you have to go in separately and delete that VLAN.dat file to wipe that switch. So that's where the information for these VLANs, for most of the VLANs, are stored, is inside this VLAN.dat file. Then we have the VLAN Trunk Protocol, or VTP. What VTP does is it allows us not to have to do as much configuration on all of our switches, and the VLAN information gets passed automatically between these switches. You would typically use this for larger networks. Otherwise, you would just go to each switch and you'd program VLANs on each of the switches. So let me give a little more in-depth answer to this. So we've talked about so far how to add VLANs to the switches, and that it gets stored on the VLAN.dat file. So each one of these switches has a VLAN.dat file, and the VLANs, when you program that switch, that information goes onto the VLAN.dat file. And so and I've had before where a switch, the devices were, the internet service provider that was providing services didn't configure one of the switches correctly, and our internet went down because of it, and they forgot one of the VLANs. So one of the solutions for that is by using a VLAN Trunk Protocol, where you set up VTP to operate on each one of these switches. And then rather than going to each switch and then entering the commands to set up the VLANs on there, instead you would go to each of those switches and you program it for this VLAN Trunk Protocol, and then these switches would talk back and forth and say, hey, what VLANs do you have? And then it would pass that information on, so that way all of your devices are operating off the same set of instructions. They all have the same VLANs configured on each one of those switches. We don't get real in-depth into VLAN Trunk Protocol in CCNA. It used to be a topic that the old CCNA had on it, but we don't need to get real in-depth into VLAN Trunk Protocol. Just to realize that it distributes the VLAN information to the different switches. VLAN IDs. So we've talked a lot about VLAN IDs, and then one thing that we haven't talked about yet is there are some ranges for these VLAN IDs. So first of all, we already know that VLAN 1 is our default VLAN for Cisco devices. So that is our default VLAN. And then the range that you can assign to your VLANs are from 2 to 1001. So you can assign actually quite a few VLANs to your devices. So that's the normal VLAN range that you can assign to your devices. Then as we saw in our last video, that we saw that there is a range that's automatically assigned to those devices that are configured for FDDI and token ring. So those are already automatically configured by default onto your devices. Then we have this extended range right here. And the extended range does operate a little differently. So number one is the extended range isn't something that we program like we program the normal range. We have to actually use VTP to send that information out. It doesn't get stored in the regular VLAN.dat file either. Because it gets distributed out to these different devices, it remains in the running config as it gets distributed to the different devices. Not all switches support the extended range, so don't plan on seeing that on every single device that's out there. It doesn't support all of the features that the normal range does. So there are some limitations to what features that this extended range does support. So they're a little different. You have to enable this range in order to use that range, but just realize that there is this extended range if you have lots of different VLANs that you can utilize if you got this really large network. There you have it. We started out by talking about interface types. That's the access ports that we have, the trunk ports that we have, and the switch virtual interfaces that we have. Then we went into types of VLANs, whether it be default, data, a voice VLAN, management VLAN, and the native VLAN. We got into the VLAN.dat, briefly talked about the VLAN.dat. We talked about the VLAN Trunk Protocol and how we can distribute VLANs to the switches rather than manually program them on each of the switches. And we ended by talking about some of the VLAN IDs and which VLANs can we assign to our network.